Welcome to Climate and Comfort presentation.
Introduction.
The building sector contributes to almost 40% of the total carbon dioxide emissions, and 28% of that portion is produced by the building operations. By 2040, the current building stock will still be emitting CO2 if no intervention was made. In this project, a study of the sustainable strategies that can be applied in the UK will be investigated. The building is a public library inspired by the many educational facilities and students' accommodations that are surrounding the site. This makes the designated library a hub for researchers and students to seek a place for knowledge and exchange cultural socializing. Our project is located in Chatham, a town in North Kent, southeast England, distinguished by short summers and partial cloudy weather, whereas winters are lengthy and generally cloudy. The temperature ranges from 3 degrees to 22 degrees throughout the year, and it is rarely falling below -2 or rising over 27 degrees. The prevailing wind is northwest with a mean velocity nearly 5.6 meters per second.
The plot is surrounded by Medway River and residential buildings from the south and southwest direction, and a walkway in front of the plot facing the river. 3 metro stations are surrounding the site, linked the plot by a walkway, in addition to Doust Street, which is the main access to the plot from the southeast direction. The function of the building was selected upon the needs of the area that is surrounded by more than 5 universities, with a lack of public libraries to serve the needs of the student. The plot is served by multifunctional nearby areas such as educational, commercial, and restaurants. The east main access of the site is going to be from the southwest facade facing the river, from the Doust Street for a smoother car drop-off area. One of the main features of the building that will be studied is the dynamic facade. The inspiration of opening and closing mechanism was inspired by the butterfly wings. The shape of the shading elements is a direct mimicry of the shape of butterfly wings, and the facade is brought to life by opening and closing in the similar linear axis rotation found in the butterfly. This slide shows the process of design development of the kinetic facade feature. The concept of the facade mechanism is based on the motion of one supergear connected to 2 rotating supergears from one side to create a rotation around a central axis. This slide shows the building layouts: ground floor, first floor. Based on the climatic conditions, we focused on passive heating through low emissivity of windows facing the south direction, at the same time reducing U value to minimize heat loss. In the base case, we followed the UK minimum building regulations. In the efficient and kinetic case, we followed the BREEAM rating system. Optimal orientation. After specifying the base case construction material based on the UK building regulations, the orientation of building was tested to optimize the energy consumption. The calculations showed 2 low values due to restrictions of site boundary. We went with the second lowest orientation. These are the 3 dates selected from winter, spring, and summer scenario. The timings fixed on those dates are 9 a.m., 12 p.m., and 3 p.m. This is the solar exposure on the building for the whole year. The sun exposure on the selected dates assisted in developing the scenarios of the kinetic facade: winter scenario, spring scenario, and summer scenario. 3 angles of the facade will be tested: 0 degree, which describes the angle between the facade and the kinetic element, 45 degrees, and 90 degrees. Winter scenario. These are the tested angles of the kinetic facade based on the solar exposure: 9 a.m., 12 p.m., 3 p.m. We tried to switch off the heating system, but the temperature in the base case was 7 degrees and 10 degrees in the kinetic case. So the heating system will be on in both scenarios. For the solar gain, the kinetic case increased 18.9% at 9 a.m. and 7.38% at 12 p.m., but the solar gain dropped at 3 p.m. by 5.7%. Illumination was reduced by more than 50% from base case to kinetic case, and the value is within the standard lux range. The maximum value of daylight factor was reduced by 14% from base case to kinetic case. The daylight factor from the kinetic case is considered higher than the standard. Sun exposure was reduced by 1.2% from base case to kinetic case. The psychometric chart shows a slight improvement from base case to efficient case, and almost the same readings from efficient to kinetic, but it is still far from the comfort zone. The inner temperature decreased by almost 4 degrees due to the use of kinetic facade. The computational fluid dynamics show a slight increase of the wind velocity from almost 0 to 0.2 meter per second, which is above the ASHRAE acceptable rate of 0.15 meter per second in heating mode. PMV shifted from almost negative 0.8 to negative 1.39, which is further from the neutral PMV scale.
Spring scenario. These are the tested angles of the kinetic facade based on the solar exposure. We tried to switch off the heating and cooling system for the base case and the kinetic case. The temperature at 9 a.m. is below the thermal comfort, while 12 p.m. and 3 p.m. falls in the comfortable range. So we will use the heating system for a limited time in the morning in both cases. Optimizing the kinetic facade led to the increase in the solar gain by 19.56% at 9 a.m. and 6.26% at 3 p.m. A slight decrease occurs at 12 p.m. by almost 2%. Illuminance was reduced by more than 50% from base case to kinetic case, and the value is within the standard lux range, blocked by the closed kinetic facade scenario in the south facade. A significant decrease in the maximum daylight factor is found from 40% to 21%. We tried to maintain the solar exposure on the kinetic facade in the spring scenario to achieve thermal comfort. The base case and the kinetic case are almost the same. The psychometric chart shows the base case, efficient case, and kinetic case close to the comfort zone and considered acceptable to the adaptive thermal comfort model. The inner temperature increased by almost 2 degrees. Air velocity decreased from almost 0.1 meter per second to reach nearly zero. PMV is slightly enhanced and closer to neutral in kinetic case. Summer scenario. These are the tested facade angles based on the solar exposure. We tried to switch off the heating and cooling system for the base case and the kinetic case. The temperature at 9 a.m. is below the thermal comfort, while 12 p.m. and 3 p.m. falls in the comfortable range. The kinetic facade acted as a light shift that increased solar penetration. The solar gain increased by 20.9% at 9 a.m., 2.91% at 12 p.m. and almost 4% at 3 p.m. The illuminance level significantly decreased to the standard acceptable range. Daylight factor decreased to reach the maximum of 21%. The sun exposure in kinetic case decreased slightly. Psychometric chart shows proximity to the comfort zone in all three cases. The inner air temperature nearly increased by 3 degrees from 19 to 22. A slight decrease of air velocity is found in kinetic case. The PMV is enhanced by 0.2 and is closer to the neutral in the kinetic case. Energy consumption. By applying the facade strategies, we were able to reduce energy consumption by 19% from base case to kinetic case. Reducing energy consumption of buildings is one criterion of the BREEAM rating system. For this building, we used PV panels with high efficiency. Total roof area covered with PVs that are oriented to south direction is 1,309 meters square, with a panel size of nearly 1 by 1.8 meters. The total number of panels used is 693. The result showed almost one-third of the building energy consumption can be covered by the PV system. Life cycle assessment. Comparing the LCA of the base case and kinetic case, the amount of CO2 equivalent in the kinetic case is 38% less than the base case. The embodied carbon in the base case is 44.56 kg CO2 equivalent per meter squared, while in the kinetic it is 27.44 kg CO2 equivalent per meter squared. In both scenarios, energy consumption has the highest impact on the global warming. BREEAM assessment. Assessors in the BREEAM rating system evaluate the buildings through credit points for each rating category. According to the preliminary score, the assessment of our building is good. In conclusion, the kinetic facade provides flexibility in the design to fit the climate and indoor environment. Our building design enhanced solar gain and minimized heat loss to conserve energy.